going to have 2 pi over 3. That's in the second quadrant, right here. And then I'm going to have third quadrant, 4 pi over 3. So those are my 2 possible solutions for cosine of x equals negative 1/2. Next, we have cosine of x equals negative root 2 over 2. No solution or no solving necessary here. All I need to do is find where does cosine of x equal negative root 2 over 2. Again, I'm talking about cosine, and I'm talking about a negative value. X is negative in quadrant 2 and quadrant 3. Anytime I have root 2 over 2, I'm always talking about 45-degree angles. So in this particular case, x would have to equal 3 pi over 4 and 5 pi over 4 are my 2 possible solutions. And again, the sooner you memorize the unit circle, the sooner you're going to be able to just spit answers off like I'm doing right now. Otherwise, you should be referencing your unit circle during this process. 2 times the sine of x minus the square root of 3. They're still making this fairly easy on us. Equals 0. Now we're talking about a 2-step equation, so I've got to add root 3 to both sides. So 2 sine of x equals root 3. Then I need to divide by 2. So I end up with the sine of x equaling root 3 over 2. I'm talking about sine, I'm talking about positive. That means I'm talking about quadrants 1 and 2, because that's where y is positive. And where is y root 3 over 2? I'm talking about here and here. So my answers for this would be x would have to equal pi over 3 and 2 pi over 3. Number 6. Maybe. Waiting. There we go. Recall the graph of sine of x, cosine of x are periodic. What are their domains? So a little simple question here, a little review. Domain of both of them is all real numbers. The range of both of them is -1 to 1. What shift value would result in no change to these graphs? So if I wanted to, in other words, if I wanted to take a sine graph, how far would I have to shift it to the right so that it ends up being equal to itself? In this case, I would have to shift it the length of one period, which would be 2 pi. The same thing applies for cosine. How far would I have to shift the cosine graph? Alright, so that I end up getting the same picture over again. And again, that is 2 pi. Number 7, the graph to the right is sine of x. Use the following questions to help you find all the values of x. Output is equal to 0. In other words, follow the steps to solve the equation sine of x equals 0. How many solutions are there between 0 and 2 pi? So that's what we were doing. So if I look between 0 and 2 pi, that means I'm starting here and I'm going to here. How many solutions? There are 3. How many solutions are there if we do not restrict the domain? There would be unlimited solutions, because sine of x will continue to equal 0 every pi units. We need a way to express all of these answers. There is one value that we can add or subtract from the solutions in part B to get all the other solutions. What value is that? Why does it work? In this particular case, you see that the intersection point is every pi. So if I wanted to say what are the solutions to y equals sine of x, okay, so when does sine of x equal 0 in this particular problem? X equals 0 at every pi n radians, where n is an integer. And then some of that is just looking at the graph and I see 0, I see pi, I see 2 pi, so forth. Alright. Then I would have -pi, -2 pi, -3 pi, -4 pi, so forth. So every pi, I'm having a solution. Will it always be that easy? Certainly not. Let's take a look at number 8. And number 8, Nikki was solving the equation sine of x equals a half, got pi over 6 and 5 pi over 6 as her solutions. She is correct for the domain 0 to 2 pi. To see the rest of the solutions, it is easier to look at a problem graphically. So we see the graph that goes all the way from negative 6 pi to 6 pi. Adjust your window settings so the graph looks like the one below. Be sure you are in radian mode. How many solutions are there between negative infinity to infinity? How many can you see on your calculator screen below? Well, on the screen we can see 2, 4, 6, 8, 10, 12 on the screen. However, we know that total, alright, there would be infinity. There would be an infinite number of answers. Okay? Now on the letter B, we're going to look a little closer here at how to actually describe that. There is a lot of symmetry that occurs. We can use this symmetry to generate all the solutions. So for example, we can't add pi here, okay, because from this solution to the next time this one occurs, which is here and the graph is increasing, is this answer right here. And then the next time that one occurs is here. All these answers have to happen at equal intervals for us to be able to add something to it. So here we have to say x equals pi over 6 plus what is the interval from this solution to this solution to this solution and even backwards. Alright, whenever we're on that increasing side of the curve. That will be 2 pi n. So every 2 pi n that happens. However, we're only talking about half of our solutions. The other half happen here on the descending part of the curve. Okay? Again, this is not an equal interval from here to here. So that's why those two are not related. We got to go all the way to this next answer and then this next answer. And again, we're looking for where we have a solution and the graph is decreasing. So those are 5 pi over 6 plus 2 pi n. Will these always be the same? Certainly not. And that's what makes this part of it so difficult. Since we know that the sine curve can be depicted as a wave or y coordinates a unit circle, we also use unit circle to visualize this. So again, here's your 1/2. Alright, that's your pi over 6. It will never reach that solution again, okay, until it travels all the way around the circle back to here. That's why we have the plus 2 pi. And we can't add this onto it to get this solution, because if we add that again, we're not going to end up there. We're going to end up down here, and that's not a solution. So you must add equal intervals. Okay? Long section here on the 6-10. That is math notes box. I want you to push pause and copy that into your book or into your notebook, and that is the conclusion.